In today's world, digital data is everywhere. Every photo, video, message, or document we create adds to the enormous amount of information stored on computers, phones, and the internet. To understand and organize all this information, we use units of digital storage. Most people know about gigabytes, GB, or terabytes, TB, because they appear in devices like smartphones or laptops. But beyond terabytes is the petabyte, PB, which is a much bigger unit of storage. Petabytes are important because they help store and manage huge amounts of data, like the content on YouTube or the data produced in science and industry. What is a petabyte? A petabyte is a unit of digital storage that is very large. 1 petabyte belongs to 1024 terabytes. 1 petabyte belongs to 1048 576 gigabytes. To imagine how big a petabyte is, think about the following. Photos. If one photo takes about 4 megabytes of space, a petabyte could store over 250 million photos. Music. If one song is 5 megabytes, a petabyte could hold over 200 million songs. Videos. 1 petabyte can store about 200,000 hours of high-definition video. Even though most people don't personally own a petabyte, we encounter them every day. Streaming services, social media platforms, and cloud storage companies deal with petabytes of data to make our digital lives smooth and fast. Digital storage has changed a lot over time. In the early days, computers used floppy disks, tiny disks storing just a few megabytes, and magnetic tapes. Later developments, hard drives appeared with gigabytes of space. By the 2020s, personal computers often had terabytes of storage. Cloud and internet. Today, many companies store data in the cloud, which is a network of servers that can handle massive amounts of information, often in petabytes. The need for petabyte-scale storage grew as people started uploading millions of videos, playing online games, and creating huge amounts of digital content. 1. Petabytes in everyday life. Even if you don't own a petabyte, you use it every day through services and apps, streaming videos. Platforms like Netflix, YouTube, and TikTok store millions of videos. All this content is stored in databases that add up to petabytes. This makes it possible to watch videos instantly on your devices. Cloud storage services like Google Drive, iCloud, and Dropbox store your documents, photos, and backups online. Individually, your data might only be a few gigabytes, but millions of users combined make petabyte-scale storage necessary. Online gaming. Big online games like Minecraft or Roblox store worlds, updates, and player data. This requires petabytes of storage to let millions of players interact at the same time without delays. Social media. Social networks like Facebook and Instagram store billions of photos, videos, and messages. Petabyte-scale storage allows users to upload, view, and share content instantly. Petabytes are not just for everyday apps. They are crucial in science, technology, and business. Science. Astronomy. Telescopes collect millions of images of space. Petabytes of storage are needed to save these pictures and measurements. Genomics. Sequencing human genomes creates hundreds of gigabytes per person. Studying thousands of genomes requires petabytes. Climate studies. Weather and climate models generate huge amounts of data that scientists store in petabyte-scale systems. Artificial intelligence, AI models need large datasets to learn patterns. For example, image recognition or language translation programs require petabytes of data to work effectively. This data is stored and processed in large servers and cloud systems. Businesses. Companies generate massive amounts of information daily. Transactions, customer interactions, sensor readings, and more. Petabytes of storage help businesses analyze data, improve products, and make decisions. Healthcare. Hospitals store MRI scans, X-rays, CT scans, and patient records digitally. Storing this medical information often requires petabyte-scale infrastructure to keep records safe and accessible. Storing a petabyte of data is expensive and requires infrastructure. Cloud storage. Services like Amazon Web Services, AWS, or Google Cloud charge per terabyte. 1 petabyte could cost $20,000 per month for active data storage. On-premises storage. Companies storing data in their own facilities must buy hard drives, servers, and cooling systems. Maintaining a petabyte in-house can cost over $1 million over several years. Data centers. Petabyte-scale storage is usually kept in data centers with controlled temperature, electricity, and security to prevent loss and damage. Challenges. While petabytes allow us to store huge amounts of information, they come with challenges. Managing data. Organizing and retrieving information from petabyte-scale storage is complex. Speed. Accessing massive datasets can be slow if the system isn't optimized. Energy usage. Large data centers consume lots of electricity for running servers and cooling systems. Physical limits. Storage devices have size and lifespan limitations. New technologies are being developed to store more data in smaller spaces and at faster speeds. Advanced SSDs and NVMe drives make storage faster and more reliable. Petabyte-scale thinking will continue to be important as AI, cloud computing, and global digital communication expand. A petabyte is an enormous unit of digital storage, over 1 million gigabytes. While we may not personally own a petabyte, it powers much of the technology we use daily, from streaming videos and playing online games to cloud storage and social media. In science, business, and healthcare, petabytes allow organizations to store, analyze, and preserve massive datasets. Understanding petabytes is important because it helps us appreciate how modern technology manages the ever-growing amount of digital information around us. As digital data continues to grow, petabyte-scale storage will remain essential, bridging the gap between personal devices and the vast digital infrastructure of the modern world.